Hello, have a good day, ladies and gentlemen. Many thanks for attending my presentation today. My name is Martina Hahnen, and the topic of today's presentation is IonicLife high performance copper coolers. So let's start at the beginning. So what I'm going to present today is an introduction of who we are, who Metop is, and about our product portfolio. And then I'm starting to give you insights of our new casting concepts with high performance copper in copper coolers. So, as I said before, let me just find my laser pointer. So we in Metop, we are located in Leoben, we are in Austria. We are an engineering company of metallurgists, so we have a deep knowledge about metallurgical processes. Our core topic is copper production route, so we're a team of non-ferrous metallurgists. That's also why we came to the topic of the copper coolers. So as you can see here, Pira Industrie AG is part of our Metop company, and we in Metop, we are part of Welding Copper, which is a copper foundry located in Spain. So that's why we have this know-how about the copper coolers, because of also of our partner sitting in Spain. So let's come to a short overview about our products and services. So you can see here we have a very wide range of products and services and technologies, more or less all based in the non-ferrous industry. So we do have some non-ferrous metals production units, which are designed by us. So we have a special kind of TBRC, also the Henry furnace. Also we provide gas purging systems. So we do deliver key components. We've also very deep insight in refractories in the non-ferrous industry. So we all do 3D engineering. We are all with the help of CFD modeling and thermodynamic calculations. We provide a refractory concepts for the non-ferrous industry. We do not have any production site. With our daughter company, Urban Gold, we are deep in e-waste recycling, so starting from project development, via studies to process engineering, coming to the best possible technology you need for your e-waste recycling. Also, one of our core competencies is in tank house technologies. So we have a patented system, the Metop BRX system. And coming from all those know-how about the different furnaces, different processes, we have developed the ILTEC cooling technology. I was giving a talk 2 days ago on Tuesday about the ILTEC technology. So we provide safe cooling for metallurgical vessels, and especially for highly stressed area for hotspots. This is also part of the IonicLife cast technology, but I will come to that right after. We also do overall process technology consulting. We do field studies and trainings, so our product portfolio is quite big. So let me start to tell you about our new casting concept, IonicLife cast, and especially what is new about. So when you think of copper coolers, you need to cool those copper coolers once it's in the furnace with water, which is in the cooler. So our technology is to have these copper pipes in the copper matrix, so giving you the perfect bonding, giving you the perfect cooler. So, but how can we do this? Because during the casting, if you would just pour the liquid copper on the copper piping, it would simply melt away. So there is also the chance of cooling it via pressurized air, but this is not enough cooling. You can also fill it maybe with sand, which provides some cooling, but not enough. You could cool it with water, but no, nobody wants to cool it with water during the casting process. And now we come to the ionic liquid technology. So we have a safe way for cooling those pipes during the casting process, which takes out enough energy to give a real nice bonding between the copper pipe and the copper matrix, but in a very safe way. So this is the concept of IonicLife cast, to cool the copper pipes during the casting process with the water-free ILTEC technology. So just some words about the ILTEC technology and the ionic liquid, which we are using for that. So an ionic liquid is a salt. You can see here in the small video where this ionic liquid is pumped into liquid copper. Now it's even pumped beneath the surface. So you can see, even in case of any hazardous or problems, there won't be any explosion at all, since there is no vapor pressure within the ionic liquid. And we as METOP, we hold the patent for using this ionic liquid for metallurgical applications. So that's how we invited this technology. So let's start one step back. Let's make one step back. So just give you an idea about the different concepts of how to produce copper coolers, and after why the coolers with IonicLife cast have these superior properties. So how can you cool any copper cooler? You can either drill the cooling channels in the already casted copper block. You can cast steel pipes, which is actually not very common in use. More common is to cast Monel tubes. So Monel is a copper-nickel alloy. You can also have, as I said before, sand-filled copper pipes during the casting process, which also gives a lot of limitations, since you cannot go too big or geometries are not too easy. You can also cast with the help of sand cores, but the best way to do is to cast the copper on copper tubes. So once again, here we go with our IonicLife cast technology. So I tried here to make some kind of metrics who compares the different possibilities of producing a copper cooler with the different important properties. So one important property is if you have a good bonding of the pipe and the surrounding matrix. What is also of superior interest is the thermal stress resistance. So, you know, every cooler is cooled and heated and cooled and heated. Some more, some not so often, but especially thinking of launders, you have to really have a good thermal stress resistance. What also comes in mind more and more nowadays is also the recyclability. So how easy is it to recycle your copper cooler? Of course, the lifetime of the cooler is of superior interest, but it is also the geometry limitations, or let's say geometry possibilities. So how easy is it to design a cooler? And also if the water flow, if you can guarantee an homogeneous water flow during the entire copper cooler. So I will not lead you through the entire matrix. Just let me come to our IonicLife cast coolers. So because of it's the same material, so it's copper pipes and copper matrix, you have superior bonding between those two parts. So actually it's just one part at the end. Because of that, because of the two identical materials, you have a perfect thermal stress resistance. You can also quite easy recycle those coolers. So it's just pure copper. You can just remelt it. Also the lifetime is very, very nice. And you're also not really limited with geometries, since the copper pipes are very, very easy to bend, very easy to produce. You can think of very, very difficult geometries. And also, since it's water just in the pipes, you don't have any cold spots or hot spots like you have in open water circuits. So this is very unique about these coolers. So just to sum up, you have a perfect union between the cooling circuit and the copper matrix. You can recover the value of your piece of your copper to 100%. There is no nickel in it. It's just pure copper. And also you have the coolers with up to 100% EASC. So you have the best thermal conductivity, meaning best cooling performance. And since the ionic liquid as cooling medium is not explosive, you have a safe production method. So some fundamental aspects behind all those nice properties I told you. So you see here just some microscopic pictures of different cooling pieces. And what you see here is with the IonicLife cast technology, you really get this nice bonding between the copper pipe on the upper side and the copper matrix on the lower side. So actually you see the grain growth throughout this boundary. Actually, there is hardly any boundaries, so it's really a perfect interface, which is not shrinking, and you have a long-term durability. So also what it's nice about coolers produced with this technology, so you don't have any deoxidation with phosphor. You have a very precise control of the casting temperature. You can control the thermal energy because you can control the cooling, so you can either drag out more heat or less. And with the help of the electrolytic coating with silver, so the copper pipes are with a very thin layer coated with silver, which gives this extreme nice bonding between copper pipe and copper matrix. Why is this so important? Why is high purity so important? So whenever you think of any impurities in the copper at all, you decrease your electrical conductivity tremendous. So if you really have only copper, you can go up to 100% EASC, and this is only possible with this special casting process. And last but not least, so I told you a lot about good properties, nice properties, just show you some references, and I want to pronounce it's only some of the references. So, especially as I said, because of the thermal stress resistance, we have already casted a lot of launders, so not only slag launders, but especially there the high thermal stress sensitivity is very important. So we started with this special launder. We started the operation in June 2019, and actually the lifetime should be around 6 months. And I have to say it is still in operation, so it's more than 2 years now with one slag launder, which is very, very nice. Actually, it's not so nice for us, so we don't sell as much launders as we want to, but for the customer, it's perfect result. 2 years of operation for a launder. Also, this is a curved launder. This is also in operation almost 2 years, where the prognosed lifetime was only 4 to 5 months. So also very nice result for our customer. What's also very important is different sidewall coolings, especially at highly stressed areas. So you can see here, this is a high intensity cooler, so-called CFM cooler, which drags out so much heat, you create a frozen layer on top of the cooler. So you can see here, this part is going to be casted with some refractory castable. And because of the high heat removal in the furnace, you create a layer of frozen slag or frozen melt, which gives more or less infinite lifetime. And even in hotspots. Also, different kind of tap holes can be realized with our casting technology. So you can see here more or less, let's say, a normal tap hole. But on the right-hand side, you can see it's a special designed tap hole designed by Metop for a fellow alloy furnace, where you also have the casting loops inside with this copper fingers. So you have a cooled area also at the very front. So this is a very nice cooling products. And this was more or less one of our last products we cooled with the IonicLife cast. It's a blast furnace 2-year. So we changed some design. So we have here also the casted tube inside the blast furnace 2-year. They're actually just about to be shipped and to be installed at a blast furnace in Europe. So as I said, this is just some of our examples. So just to keep the good things in mind, let's sum up what's so special about our IonicLife cast technology. So it is high purity copper casted directly on copper tubes. So you have a perfect bonding, which provides best thermal conductivity. Also, since it's just copper in copper, it provides perfect recyclability. You can directly remelt it and gain the full copper value. So the entire cooling circuit is made from one piece. So there is no welds, which is also very good because welds are always a weak spot in every cooling loop. You think of Monel pipes, always it's always the welds, but this is just a banded copper pipe without any welds. So with this casting technology, but also with the know-how of our partner Veco in Spain, the copper coolers are up to 100% EASC, which provides the absolute best thermal conductivity. And last but not least, the IonicLife cast technology is a safe and cost-effective solution for advanced copper cooling elements. So you can really think out of the box for designing your copper cooling elements. So actually, I am finished with my presentation. Thank you very much for your attention. Hopefully we see us next time face to face again. Stay safe and healthy. And if you have any questions, please feel free to contact us and let's together think outside of the box. Again, thank you very much. Goodbye.